Hello children, good evening.
Good evening, ma'am.
Yeah, keep your videos on. What happened, Harshit? Not well.
I just woke up.
So today we will do case study on human eye and colorful world. Okay. Did we finish the exercise questions? Did we finish the exercise questions? No. Okay, then first let us do the exercise, then we will go to case studies. 1 minute.
I think we're done.
No, only MCQs we finished.
Uh,
1 minute, it's still opening. A person needs a lens of power minus 5.5 diopters for correcting his distant vision. For correcting his near vision, he needs a lens of power plus 1.5 diopter. What is the focal length of the lens required for correcting distant vision and near vision? So here, what is given? They have given power of both the vision, correct? For distant vision, for the first one. For distant vision, what is the power given? Minus 5.5 diopter, correct? And then for near vision, the power is given as plus 1.5 diopter. Now what is asked? Focal length is asked. So f is equal to 1 by p. F is equal to 1 by p. So it is minus 1 by 5.5, and here it will be 1 divided by 1.5. How much is that? Do the calculation and tell me. How much, children?
Minus 18.2.
18.2 you got. How?
It
1
is
divided.
0.182.
Huh.
I just shifted it
Centimeter
because
then.
of centimeter. Yeah.
Huh. So it is minus 0.182 meter, or you can say F is equal to minus 18.2 centimeter. Okay. Here 1 by 1.5.
Oh, and I divide one like 1 upon 1.5, getting 0.6666. Yeah.
So it is 0.667. We can approximate it to that much meter. Okay. Shall we move on to the next question? Now, what is this? Video is in the middle. 1 minute. The power of a, excuse me, the far point of a what person?
Myopic person.
Okay. The far point of a myopic person is 80 centimeter in front of the eye. What is the nature and power of lens required to correct the problem? So myopic means the person is with myopia. So myopia means the person cannot see the distant object or near object. Myopia is short-sightedness. The person will not be able to see things which are at distance. Okay. Now, the question given here is the far point of a myopia person is 80 centimeter in front of the eye. What is the nature and power of lens required to correct the problem? Okay. So now which type of lens should be used? Now what should be the far point for a normal person? Far point should be infinity, correct? So for a normal vision, far point should be always equal to infinity. So you can say the y- object distance, that is u should be equal to infinity, right? But here for the defected person, for defected person, what is V? V is equal to minus 80 centimeter because it is in front of the eyes. Okay. Now what is asked? They have asked the nature and power. So to find nature and power, first let us find F. So 1 by F is equal to 1 by V minus 1 by U.
F is minus 80.
Okay. Now how much is power then? 1 by F. So F is in centimeter. So if you convert into meter, you can write it
Two
minus
zeros will go
80
on
into
top.
10 raised to minus 2. Or you can just write
100.
100 divided by
Yeah.
80. So minus 100 divided by 80. So you will get the power also in negative sign. 1010 cancel. 2 fours are 8. 2 fives are 10.
2.25. No, no, wait. 1.25. Yeah, 1.25.
1.25 diopter. That is your answer. Okay. Shall we move on to the next one, children? Okay. Make a diagram to show how hypermetropia is corrected. The near point of a hypermetropic eye is 1 meter. What is the power of the lens required to correct this defect? Assume that the near point of a normal eye is 25 centimeter. So now let us so here what is u? U value is minus 25 centimeter. V is how much? 1 meter is nothing but 100 centimeter. It is given to you. Okay. So let us find how much is F. So 1 by F will be equal to 1 by V minus 1 by U. That is 1 by 100 minus of. Now V also is negative only, no, because it is in front of the lens. In front of the eye only it will happen, correct? So that is also negative. So this will be minus of minus. So I can write it as plus 1 by 25. Now tell me how much is 1 F.
Hundred upon 3 centimeter. And then if I think we have to we have to convert it into meters. So 1/3.
So now power is 1 by F, which is equal to 3 by 1. That will be plus 3 diopter.
Yeah.
Now shall we move on to the next one? And then here you have to draw the diagram. Will you people draw it? One minute, children. Now we will move on to the next one. Why is a normal eye not able to see clearly the objects placed closer than 25 centimeter? What is the reason? A normal eye cannot see clearly the objects that are placed closer than 25 centimeter because the power of accommodation will be how much? Of 25 centimeter. Okay. Understood this? Children, give me 1 minute. My daughter is crying very badly. Finished, children? Shall we move on to the next one?
Yes, ma'am.
Okay, the next question is what happens to the, I can't see what is here actually in this region.
Image distance in the eye when we increase the distance of an object from.
So what will happen? What happens to the image distance in the eye when we increase the distance of an object from the eye? So when the distance of the object from the eye increases, what will happen? For a normal eye, I mean, for a person with normal eyesight, if you increase so for a person with normal eyesight, if you uh, increase the distance, so even if you increase the distance or you decrease the distance, the image will be formed on the same retina, correct? Yes or no? Therefore, the image distance also will be same. Understood? So how will you write the answer for this? You write down, I'll dictate. The eye lens, the eye lens of a normal eye, forms the images of a object, forms the images of the object at various distances, on the same retina, on the same retina. Therefore, the image distance in the eye remains the same. Image distance in the eye remains the same. Okay, got it? So now this one, I think you know the answer. Second one, I mean question number 10. Why do stars twinkle?
Yeah, you made us write it before.
Yes, this explain why planets do not twinkle. Can you tell me this?
Because planets are closer than the stars.
Correct. Planets are closer than the stars. Therefore, you can consider that these are similar to sun at night. Okay. So that's the reason it does not twinkle. Okay. Okay. Then, why does sun appear reddish early in the morning? What is the reason for this? Why does sun appear reddish in the morning?
Ma'am, like most of the small wavelength, like the blue color,
Hmm.
they scatter off. So the light reaching the larger wavelength, which is the red one,
Hmm.
that because of that the sun appears reddish during the sunrise and sunset.
Yes, correct. So write down. The light coming from sun, the light coming from sun passes through various denser layers of air passes through various denser layers of air in the Earth's atmosphere before reaching our eyes. Before reaching our eyes near the horizon. most of the part of blue light and the light of small wavelengths and the light of small wavelength gets scattered by dust particles near the horizon. Gets scattered by dust particles near the horizon.
Ma'am, I know the answer for the next one also.
Mm.
Should
What
I
is
tell?
it? Yeah.
Yeah, when the astronaut goes like above the earth, it like
Mm-hmm.
okay. Yeah, so it moves away from the Earth's atmosphere, and
Mm-hmm.
like due to that, all the particles in the air,
Mm-hmm.
like it'll move off, so there'll be no light, so the sky will be dark instead of blue.
Okay, so when an astronaut moves or an astronaut like as you move away from the atmosphere, the atmosphere becomes thinner, correct? So due to the absence of dust particles or air, the scattering of light will not take place. That is the reason sky appears to be dark. Okay. Should I dictate it?
I wrote.
Okay, fine. So this is the end of the chapter. So how much time is left out? Okay. So 15 more minutes, we'll wind up the class for today. And in the next class, we will start the case study for this chapter. Okay. Now, any doubts,
No, ma'am.
everyone? Okay, then. So we'll wind up the class for today and we'll continue in the next class. Okay. Yes. Thank you, everyone. Bye.